Session, we are going to discuss a new topic, the so called file system. So far, we had seen a variety of topics starting from variables, then, we had seen how to store and process data in an array, and then later, we had seen how to store and process data in a linked list. But then, let us shift our focus to what we call as a secondary storage. And then let us talk about how we can store and process data that resides in a file system. Firstly, let us look at what a file system is and how it is connected to the discussion that we had so far. So, as you could recall that from our earlier discussions, we did say that CPU would be the control unit and the central processing unit, which is where all the core operations happen. And then you can see that the CPU is connected to the main memory, as we often call that as RAM. Every time we store the data inside a variable or an array, a linked list, stacks, queues, and so on, which we had not discussed yet about stacks and queues, but we will discuss that in the next few lectures. So, all these are going to be situated inside the main memory. And you can tell that the main memory, often represented as RAM, has a lesser space compared to a secondary storage. But then the main memory is situated closer to the CPU, and thereby any data that's residing in the main memory can be accessed in a more time efficient way, right? Meaning it will be more faster to access the data from main memory than from secondary storage. Why? Because secondary storage is located far away from the CPU, whereas main memory is located closer to the CPU. But then the disadvantage that we have in main memory is we cannot store a lot of data in it. Usually the main memory, in terms of the RAM size, in a typical machine, you could see that it's 8 GB, right? In different laptops that's manufactured today, in a standard one, we could see it's being shipped with 8 GB. Whereas secondary storage, what we call as a hard disk, can hold up to 1 terabyte of data. So clearly, the secondary storage can hold a lot of data, whereas main memory can only hold smaller amount of data. So then the question comes in, how can I access the secondary storage, let us say a file that resides in a hard disk? How can I access that from a Java program? So this discussion that we are having now in this new topic is clearly going to address that question. I'm going to write down the question: how can we store and process data in a file from a Java program? So it's an important question that we should pay attention to and focus on, so as to make sure that we know how we can process and store data in a file from a Java program. So in order to do that, you could go to our starter code. I like to go over variety of starter code for today. You would find that there are 4 files inside the src directory. So let's open the file utility. So I had created this program for us to easily perform file-based operation such as read, write, and update. So whenever we talk about file operations, these are the 3 major operations, as in the read, where we are reading something from a file, write where we are writing something to a file, and update is we are updating some existing content inside the file, right? So clearly this particular file utility class is able to do all those three major operations. I like to go over this code briefly. So you could see that there is a path variable that's set here. A path variable is simply the path to where the file is located. And then you can see that there is a constructor where we simply set the path. If the file doesn't exist, then we would create the file. If the file exists, then we can read all the file content, right? So we use what we call as a buffered reader. I'm going to make a note here. It's called the buffered reader. Internally in our file dot read all lines, every time we are using that method here, read all lines, it will use a buffered reader, and the buffered reader is simply a stream that's connected to the file system from your program. So your program is kind of hooked up to that file system, and then there is a channel that is created between the file system and the program, so as to make sure that all the data is being communicated both ways. And then you can see a function here called read, which will simply get all the lines, right? It will line by line, it will read from the file, and then it will store that as a string. There is also a reset function. This will reset the channel. Remember, we talked about the channel between the file system and the program. So the reset will simply refresh the file just in case if there is any changes being made, right? So in other words, it will start the channel from scratch. And then there is a function here called write, which will simply write content to a file. So again, you can see that the content is written character by character internally, and then line by line, and as a file on the whole. And clearly, this particular function will write content to the file, and then an update function would take a line number as an input. It's kind of doing the similar thing as write, except that it would go and modify the content that's located inside that line number. So for example, if you want to update the content in line number 10, you should be able to do that by calling this function update. And then finally, we have a size function which will return the total number of lines in your file. And this is extremely handy for you to perform any iterative processing on the file. So the next thing I'd like to review would be the examples.java file. So this file is used mainly to utilize the methods in the file utility. So file utility is the method that holds all the major file operations that we had talked earlier. And the examples file is simply utilizing the methods that are available inside the file utility class. So we create an object for file utility. Let us call that object as dummy, and then you have a file that we have inside the data. So this is the path that we are talking about. So .data/dummy.txt. Let me open that file here inside the data folder. You should see there is a folder called data. This should be a file here called dummy.txt. So there's some simple content here just for testing purpose, right? And I'm going to close that file and go over the examples.java here. So first thing is we would like to read the first line from the text file, and store it inside a variable. You could clearly see that we are storing it inside a variable called first line. So what we are necessarily doing is we are bringing the data. If I can go back to my notes here, if we are bringing the data from the secondary storage, which is the hard disk, and then the file system, we are bringing the data from the secondary storage to your main memory. Necessarily, we are moving the data from file to a variable in this case. So the same thing is being done for the second line, dummy.read. Every time you call that read method inside the files utility, it will simply read it line by line. And then you can see there is a dummy.write end of the file, thus end this file, which will be added towards the end of the file. And then there is an update here, update method. You give the line number starts from 0, and you can see that we give a content that would need to be replaced for that particular line. And then one can get the size by calling the size function and assigning it to the lines here. And then I will, let us say if I want to do one more update, this time I want to update the lost line. So I will simply say dummy.update lines -1, because the number of lines starts from 0, so you can do a -1, which will refer to the lost line, and we can update that to be, this is now the lost line. And then we reset the reader so as to make sure that if you call the read again, then it will start from the scratch. Necessarily it just does the channel refresh. And again, we are talking about the channel between the file system or the secondary storage and your program. And then towards the end here, you would see that dummy.read is called again, and then it will simply print the first line in this case. So I like to go back and run this program here, and also compile them. So let me go into the plant directory, and then I'm going to compile this program. Then I would go into the classes directory and then run it that way, because I am using a Java C-D classes. So all the classes are located inside the classes directory. So you can see when we run this program, Java examples, we get this is now the first line. So we are printing that first line from our print statement right here after we do the dummy.read. So what if we want to print all the lines in that particular file? So then we could simply do a for loop for int I equal to 0. Keep in mind we had already done one read here, so we should do a total of size -1 number of read. So I would do lines, because lines will give you the size of the number of lines. Lines -1 I plus, and then simply let us copy these two lines and place them inside this area right here. So let me also call this a string content, and then I'm going to update system.out.println content. And let us also do a dummy.reset towards the end here, so that next time the channel is refreshed. Okay, so once we had done that, I would like to go back and then recompile the program, and let us see if we can run this program. So clearly you could see the program had outputted all the lines in the file, and it did produce that output in the console. So this is the high-level idea behind using the file utility class and performing the operations such as read, write, and update using the channel that we had created between the file system and your program. So now let's shift our focus to another variation of this problem. Let us look at the plant.java and plant-driver.java. So before we look at those individual source code, let us also look at the data file for plant.txt. We have a file here with a series of plant related information. For example, you could see there is a plant called bloodroot, and then it costs $2.44, and it needs mostly shady light, so on and so forth. So we have several plant related information in this data, and we like to create the channel between the file, in this case plant.txt, and our program, and we like to perform a series of analysis on this data through our program. And in order to do this, we would need to use our file utility a lot to perform a variety of read, write, and update operation on this particular file. So now I'm going to open up the plant driver.java. So here you can see that we created an object of file utility, and we are passing the path to that plant.txt file, and then we are creating an object for a plant class, and later we are calling the plant processor on the plant class, and then finally we are going to display the plant. So next I like to review the code for plant.java. So this function has two methods in it right now. So the first one is the plant processor. Really what it's taking in as input is the util object of that file utility class. And first thing first is it gets the size, which is the number of lines in that file. And then it runs a loop so as to make sure that we get all the plant information separately. So I like to go back to the plant.data or plant.txt. So you can see that each plant information is located between the plant tag and plant end tag, right? So you can see this is the start tag for plant, and then in line number 9 you can see that there is an end tag for a plant. Again, 10 would be the start tag for the second plant, 17 would be the end for the second plant. So all these information for the plant are located between the start and end tag. So this is what we call as parsing a file. I'm going to go back and make a note here. The process that we are learning now is parsing file to retrieve selected data items. So we are setting up a parser to parse the file and retrieve selected data items. So rather than simply printing all the lines, we are going to retrieve only selected data items from that text file. So I like to go back again to the plant.java. So you can see we had set a marker here, a placeholder marker, and this marker is used to differentiate one plant from the other. And a simple formalization that we use here is if line.contains plant, then we set that marker. If marker is greater than 0, we are going to add a new line. Every time you're seeing a /n, we are adding a new line. And this new line is added to a string, right? So this is a list of strings that it is going to return. So a string is simply a data type that will hold a bunch of characters. So in 101, we had not really used a string so much till now, but moving forward, we will continue to use string. And the concept of string should be familiar to most of you there from 100. So we will simply use the string data type. It's like any other data type, right? It's like integer, double, boolean, so on and so forth that we had used. It's simply going to hold a bunch of characters. So here we are adding the file content. We're declaring that as a string initially. And then you can see we are adding plus equal to, like any other integer, double, and so on. We are adding that new line, which is the /n, /n, to that file content. And then we check this using the formula here. If I minus marker is greater than 0 and I minus marker is less than equal to 6, then simply add that to the file content. In other words, if we can go back to the plans.txt file, you can see that I am counting the number of items inside the plant. So I'm counting from the line 3. Line 3 is counted as 1, 2, 3, 4, 5, 6. There are 6 items inside each plant. So the moment I reach 6, I would use a /n to differentiate one plant from the other. So every time you have a backward /n, then it simply means that a marker has been added so as to differentiate one plant from the other. And then finally we do a reset for our reader, and then we are doing a file contents, which was a string. If we want to take a string and then somehow create an array of strings from that, then we could easily do that using the function called split. And this split is being done based on the new line. Remember, we added a new line between each plant in the previous code that we just reviewed. So the new line is added through the marker between line 5 and line 14. And then now we are using a split so as to make sure that each plant now is a string and all the plants are going to be an array of strings. And finally, that would be returned through this method. So I like to go over the plant driver again, and then you could see that the list of plants array is created by calling the plant processor, and then we are calling display plants. We pass that list of plants as input. So if we go to plants.java, so simply we write a for loop for string item colon list of plants. So this is a way that we could iterate through a string array. So you could simply use for string item colon list of plants, and then we could print it that way. If we want to do it slightly differently, we also have an option here. If I can comment this line, we also have an option to write it like a traditional for loop, which we do with our integer array or any other array for that matter. So we could set that I equal to 0, I list of plants, and you could again go back to our plant driver, and you can see that here we have the list of plants. So I like to go back to the plants, and here we will set plant list of plants dot length, and then we could do I plus plus, and later we could print list of plants of I, like we often do. So this is also fine to be done this way if we want to display the plans. And I like to go ahead and recompile this program just to make sure that this works as we like that to be. And again, you could see the file content was printed that way. And I believe I had just accidentally executed the examples program. Let me run the plant program, plant driver. So you can see the plant driver printed all the plants information in this program. So you should also be able to receive such an output when you run the plant driver. I ask that you would execute the plant driver method, and you should be able to get all the plants related data. And again, and I like to repeat that we could either do it in the approach 1 here, where in line number 23 to 25 we are using for string item colon list of plants, or we can do it using our traditional approach. Both ways would work. Okay, so this is the display plans code. So what would be the next step for us? After we did the display, there is a lot of different implementation that we could do, which I should say is like pretty interesting to do on these plants data. Is what if we want to add a new plant, or delete a plant, or update an existing plant? We could do all those operations, and then we could also do more implementations. Let us say we ask a question: show the plant that are priced less than $5. Show the plants that require sunlight. Show the plants that are from planting zone 3. So we could ask those variety of questions, what we call as analysis, on a data file. We could implement several analysis that goes with the text file. So these are some of those things that we would see in the subsequent lecture. So for today, I like you to go into reflection.md after you had watched this video and get used to this code here. You're more than welcome to try out different implementations of this code in your own way. If you want to modify something, for example, can you try to print the number of plants in this particular program? So you may want to add that print statement in your plant driver. You're more than welcome to try out smaller things like that. But then for our class submission today, I like you to go into the reflection.md file and add your reflection here. And I like you to add your reflection about what needs to be done if you want to add a new plant, delete a plant, or update a plant. Or let us say that what should happen if you want to show the plants for question Q1, Q2, and Q3. I like you to write up your ideas or your thoughts, summarize your thoughts on how we can implement these different operations and implementation. Okay, so please add that reflection.md before end of today's session, or end of today, I should say, and then you can do a commit and push using the GitHub URL that I would be sharing with you very soon. Okay, thank you for watching this video.